Alright, so this video is for my pre-calculus class. I know you guys probably missed my voice, my lectures, teaching, all that good stuff. So I'm gonna try and teach this way for a while. And you guys can let me know if you think this works or if you want to do something else. But today we are going to talk about solving right triangles. So just a quick review. You need to know SOHCAHTOA. Sine equals opposite over hypotenuse, cosine adjacent hypotenuse, tangent opposite over adjacent. And if we're given a triangle, the hypotenuse is across from this right angle. So wherever the right angle is, across the side that angle makes is the hypotenuse. And then the angle that you are looking at across from that, or the side that angle makes, is the opposite side. So if I'm given this triangle here, this is still my hypotenuse. But if I'm looking at this angle, this becomes my opposite side, which means this is adjacent. Now, using these ratios, we have to use trigonometric equations. So the way that I always make sure that I am putting everything I need in this equation, it's always going to be trig of an angle. So trig value, sine, cosine, or tangent. And the angle can be 30 degrees, 60 degrees, 90 degrees, any angle. Trig of the angle is going to be equal to side over side. So let's say I have sine of some angle, any unknown angle measure, we call it theta, equals opposite over hypotenuse. This is how all of our trig equations should be set up in this form so that we're able to solve for missing sides and or angles. All right, so this is how some of your problems in ALEKS will look. Again, you can always come over here and get help. They have examples and explanations that might explain it better than how you feel I'm explaining it. So I'm gonna try and zoom in. Let me erase that. So the directions are to solve this triangle. And when it says solve this triangle, we want to solve for A, which is we want to solve for this angle. And we want to solve for this side and this side. So the way we would do this, we want to figure out what side are we solving for and what side are we given. So I want to solve for B. I want to solve for B first. Now, if I'm using this side, I also have to use this angle because that's the only angle I have. Of course, I can find the other one by subtracting 180 minus 90 minus 41. And you'll get the measure of this other angle. So 90 minus 41 is just 49. So we know this angle is 49. So we at least have that part. Now, to solve the other two sides, we have to set up a trigonometric equation. So if we're using 41, across from 41 is the opposite side. And we are given the hypotenuse. So between sine, cosine, and tangent, sine uses opposite and hypotenuse. So I'm going to set up this equation. Sine of the angle, so it's always trig of the angle. Sine of 41 is equal to the opposite side, which is B, over 27. And we want to solve this equation for B. Whenever you want to get things out of your denominator, you can multiply both sides by that value. Or if you have two ratios set equal to each other, you can just cross multiply and you'll get the same thing. So if I have 27 times the sine of 41, I should get B. This is just a number. So if you put sine of 41 in your calculator, you'll get a number and multiply that number times 27, or just put it in how you see it on the screen, and you will get B is approximately 17.7. And I'm not sure whether the directions say, well, what they say to round to. So that'll give us this side here, B, 17.7. And we can do the same thing to find A. But if we're still using this angle, this would be the adjacent side. So now I have to use cosine. Cosine of 41 is equal to A over 27, which is the hypotenuse. Same thing. Multiply both sides by 27, and you get 20 point. So A is approximately 20 point, what is that, 4. And we have the two side lengths as well as the missing angle. This triangle is completely solved for. Alright, let's do one more example. Here the triangle is a little bit rotated, so hopefully that doesn't confuse you. This is my hypotenuse. This is the angle that I'm given, so this would be the opposite side, which means this is the adjacent side. So we're given the adjacent side, and we have to solve for the opposite or hypotenuse. So if we want to solve for the opposite, and we have the adjacent, we're going to use tangent. I would recommend writing this down every time you're doing anything with trigonometry. So we're going to use tangent. So we have tangent of some angle. Our angle was 59, if that is 59, hopefully. And this is equal to opposite over hypotenuse. So the opposite side is A. The hypotenuse is 24. Same situation. We want to get this out the denominator. It's being divided by this thing we're trying to isolate, by this variable. So if it's being divided, the inverse would be multiplication. So we multiply both sides by 24, and we get 24 tan of 59, and A is equal to 39.9. So that is the length of this side. Now, let's say we want to find C. And I'm going to set this one up a little bit differently. So this time I'm going to actually use this new value that I got. So I'm going to use my opposite side, and I want to find the hypotenuse. So I'm going to use sine. So I set it up same way, sine of some angle, our angle is 59, equals opposite, which is 39.9, over hypotenuse, which is C. This one is different because now the variable's in the denominator, and I see people get tripped up with this all the time. But it's a variable. It's a placeholder for some number, so we treat it just like we treat any other number. We're going to multiply both sides by C. These two things cancel out. We have C times sine 59 equals 39.9. And we want to get C by itself. So this is just a number. I have C times some number. So if I want to get C by itself, I have to get rid of sine 59. And the way we get rid of things is inverse operations. These two things are being multiplied. The inverse would be division. These two things cancel out because they're being divided by each other. They equal 1. And now we have C is equal to 39.9 over sine 59, which is approximately 46.5. So that is the length of C, which makes sense. It's the hypotenuse. It should be the longest side. And then all we need to do to find B, because we know this is 90 degrees here, and a triangle equals 180, so that means this angle right here, these two angles should add up to 90. So 90 minus 59 will give me the other angle, and you get 31. So the measure of angle B is 31.